guys! Today's topic is reduction formula. So, reduction formula, it is a type of formula, especially a trigonometric formula. There is a integral value, but we'll get into that later. There's an integral meaning for the word reduction formula, but yeah, we'll be talking about the trigonometric meaning of reduction formula, not the calculus meaning. So here we go. Trigonometry. So let me just write it here. Reduction formulas. Reduction formulae. Now we'll be talking about quadrants. So quadrant 1 rules, okay? We'll be learning how to do it again with the ASTC rule. The ASTC rule is a rule that states about all sine, tangent and cosine. And we'll get into that later. Anyways, first you'll need to know the basics. So yeah. These are the degrees supported by each quadrant. So I'll come back to you guys once I am done writing that. Guys, I'm back and there's dogs barking outside. Yeah, I don't know what this is, but yeah, there's dogs barking outside, okay? So please don't ask me anything about that. But what the heck is going up? What the heck is happening? What the heck is happening here? And just stop. Okay, there we go. Now, yeah, so the basics are quadrant 1 can support 0 degrees and 90 degrees. Quadrant 2 can support the 90 degrees to 180 degrees. Quadrant 3 can support 180 degrees to 270 degrees. And quadrant 4 can support 270 degrees to 360 degrees. Now let's talk about the ASTC rule. That is prominent in what we are doing right now. So the ASTC rule is in quadrant 1 is A. So yeah, quadrant 1 is A. So all. So it can support all of these. And when I talk about saying all, I'm saying sine, cos, and tangent. Okay, so that's what I am talking about when I say A, all. Okay, then we have quadrant 2, which can only support S or sine. Then we have quadrant 3 that can only support T or tangent. And then quadrant 4 can only support as C. Wait, yeah, C. E. So C is, of course, C is cosine. Yeah, I don't know why I'm stuttering. I don't know why I have brain pauses sometimes. Yeah, this is what it would look like in a graph. So yeah, you just go away from there and draw a graph over here. This is how it will look on a graph. Okay. So quadrant 1, Q1, Q2, Q3, and Q4. Okay, so all of these quadrants, this is how it would look. In a graph, so yeah. Here you get it now, okay. 0 degrees, 180 degrees. I don't know why I have basically no space to write this, but it is whatever. My God. 270 degrees. If somehow YouTube told you to just come at this time, yeah, you might be like, what are you doing? You're a non-geometry channel. Yeah, I'm not a non-geometry channel. If you don't know, I will make videos on analytical geometry. I don't know why that's so hard to pronounce. Anyways, this is all. Yeah, if I had the space, I would write sine, cos, and tangent, but I really can't write that right now. Sine, cos, and tan, which is just sine, cos, cosine, and tangent. So yeah, that's how we will look on a graph. I don't know why I just wasted some of my time making a graph about this, but no one cares. Okay, now time to actually apply this. So we have the question sine to 60 degrees. Okay, sine to 60 degrees is, yeah. Now let's check. 260 degrees is in quadrant 3. Quadrant 3 only supports cosine. So what are we gonna do? Quadrant 3 only. Oh yeah, I kind of messed that up. Yeah, I thought this is quadrant 4, and this is quadrant 3, and this is quadrant 4. But yeah, because I really did not see that. Anyways, quadrant 3 only supports tangent. Okay, right? So we have to move away from quadrant 2 and do this and go to quadrant 2. Away from quadrant 3, we have to move away from quadrant 3, go to quadrant 2. How do we do that? Well, you just 360 minus what is the last thing supported by quadrant 2, which comes at quadrant 3. Yeah, it's 180 degrees. You don't exactly just hop into quadrant 2. You just see at the end of quadrant 2 because it's also permanent in the quadrant 3. Yeah, so like if it's quadrant 4 and you have to go to quadrant 3, you have to see 270, for example. So what is that? 180. Now, minusing this, just do a little quick. Should be able. No, I am not. 1 and 1. So it's just 1. Wait, yeah. Wait, yeah. I was trying to do it too fast. Supposed to cancel this out. When you cancel this out, 1 and 17 comes out, and then 17 in 9, then 190. So the answer is sine 190. We might be like, you have to answer this. No, that is the answer. You don't have to answer an answer. Okay? One more. Okay. Let's take one more example with tangent. Yeah, tangent what? Let's just get on to our test already. Test for you. Okay, but it's time for this. Tangent. Okay, guys, I'll be back after I'm done doing it. I'll be back after I'm done and doing all of this. Okay, I don't know what I'm doing, but okay, but anyways, I'll be back after I'm done making all of the questions. Bye, guys. Okay, so the guys, I normally do a lot of questions for my trigonometry things, but this is a way harder topic. So yeah, I'm going merciful on you and just giving you 3 sums. Yay! If you already know it, pause the video and solve it in your notebook. If you don't know it, come over here, learn it, and then come back and do the questions. But if you just want to see the answers, stay here. Okay, I'll give you 10 seconds. I'll give you 5 seconds to leave. Okay, 1, 2, 3, 4, 5. There you go. You should have left if you want to do anything. You should have gone back in the video if you want to do anything. But anyways, let's go answers. First, tangent 100. Okay, so tangent 100. You can already know that by the ASTC rule, tangent does not come anywhere close to 100. So you remember 100 minus what comes there. So 100 minus, where does the tangent in quadrant 3? Minus 180, which is of course negative 80. So the answer to the first one is tangent 100 degrees equals to negative 80. That's the answer. So next, noise. Next we have cosine 170 degrees. And let me tell you, 170 degrees is nowhere close to where cosine is. So yeah, what will we do? Yeah, here we go. Do it again. 170 degrees minus 170 degrees minus this. What was that again? Yeah, 170 minus what? Why is my brain fogging up now? 270. Yeah. Come on. Oh my god, that's a Z. Not typical 270. Now that should be 100. So negative 100. Now we are on a roll. Next we have sine. Yeah. If you did not know, you'll have to write it like this. So tangent negative 80 degrees, that's the answer. And cosine 100 degrees, that's the answer. But you don't really have to further simplify this. Actually, not 100, negative 100. There you go. Okay, anyways. We have sine 230. And yeah, now 230 is not your sine. 230 is in tangents. So 230 minus sine 0. So 230 minus 180. And you should be able to do this via normal subtraction. So 230 minus 180. You'll first have to flip it on its head. So first, no, you don't have to flip it on its head. You have to flip it on its head when it's like this, but you don't have to flip it on its head right now. I don't know what I'm talking about, but 0. And then we have 13. 1 and then 13 minus 8, which is just 5, I'm pretty sure. Yeah, it's 5. And then we have 0, 50. So sine 50 degrees. That's the answer. Now we have covered. Oh my god, what just happened? Now we just covered what is the reduction formula and how even something as hard as reduction formulas can be split down with rules like the ASTC rule. Hope you guys learned something. Hope you guys find this useful. Hope you guys enjoyed. Bye.